Halton predicted, found, and explained the Einstein cross as being four separate supernovas connected together by spiral arm filaments having intrinsic redshift components that contradict the Big Bang. The supernovas forming the Einstein cross must be at great distances with high redshifts if the Big Bang is correct. The Big Bang requires a dark matter gravitational lens that magnifies this faint distant supernova. It's an unproven supernova, a faint speck of light, one of many, in a widely predicted region. A slightly larger picture of the supernova region shows many light structures changing. They had a 30-day desperation to find a supernova somewhere in their predicted region. There are many changing and appearing light sources in the region. Supernovas are common and occur more frequently in galaxy clusters. They didn't find the predicted supernova with their 30-day timing, but they'll find better examples as they waste Hubble time.
Collect all of those data over the next year, continuing to hog all of the Hubble Space Telescope time.
What did you say, 12 billion years ago?
9.5, something like that.
Sorry, 9.5 billion years ago. Then the second image will be 9.5 plus maybe a couple of days, or 10 more days, or 30 more days. So it would just, this is how we would see a difference in the arrival time of those different supernovae. This is why we saw this one supernova 4 times a year ago, and now we're seeing it again. Did predict the supernova to appear sometime around now, plus or minus a month, not in like 2018, not in 2020, not in 100 years. All of our models, and it's several different groups using different methods, all of us predicted that the supernova should reappear pretty much now.
Appearance, this new image that we just observed, as it will follow that, it will rise in its peak over the next 100 days. We're seeing, a rerun, so we'll see the same pattern of slow rise to brightness and then decline.
Done with this cluster? Are we going to see the supernova anymore? Any more predictions?
No, that's
Get
it.
you a pair of supernova tarot cards or something.
That's it. There's another. So the models predict that there are 3 host galaxies, or 3 images of the same host galaxy, or the same spiral arm that is causing this Einstein ring around the cluster. It appears 3 times around the cluster. So there are 3 places around the cluster where you would see the images of the supernova. One appeared many years ago, one appeared last year, and the other one appears now. Our models do predict another image, but it is so faint. It's actually demagnified, so it would be fainter than if you had observed it without the magnification of.
It's an image of the arm of that galaxy where the supernova appeared, and we didn't know that a supernova was going to explode there, but as Pat said, this is a rare event, but supernovae are actually quite common, and it was really just a matter of time until we found one of these things exploding behind a galaxy that would produce this lensing effect. So we were lucky to find it, but this was, in a sense, something that we were looking for.
We were hoping to see something just like this, then.
Yeah, that's right.
The supernova is not going to increase in brightness over the next 100 days. It's unlikely a supernova. Hubble's resolution of the cluster at over 5 billion light years away is very poor, and many other light sources nearby appear and disappear.
The question was, when is that going to be? And the original prediction was, within 5 years. I think Karen had a paper that came out several days later saying, well, we know it within, I don't know, a month or 2. And so...
pretty much plus or minus a month.
Yeah, a month, yeah. So then but still people said, okay, well, they're never going to find it. You need the Hubble Space Telescope to look at it. It could take 5 years.
Don't be hogging the Hubble.
Yeah.
I was doubtful. My model predicted that we will see it around whatever November 2015, but I was like, no, it's too faint. It will be so hard to
really?
find.
So you weren't that optimistic? That's amazing. So you were probably very surprised.
I was cautiously pessimistic.
Paper came out. So you're seeing the star exploded, and this light travels away from the star, and we're looking in the middle here at the plane of the galaxy cluster, which bends the light path. So it actually the gravity within the cluster, and the gravity of this galaxy causes the light to be bent, and so it redirects this light and focuses it just like a magnifying glass or a lens in our telescopes. And so what this is doing is focusing the light towards the Hubble Space Telescope, which you see observing it on the left, and this effect of the gravitational lensing. So it's the mass, the dark matter of the galaxy and the cluster acting like an optical lens, which creates the 4 images that Pat discovered last November.
2 simultaneous supernovas occurring in over 5 galaxies is not a coincidence. It proves that the Big Bang is wrong and that Halton ARP is correct. Simultaneous supernovas are connected by filaments and make appearances of Einstein crosses. The distances to supernovas is incorrectly determined. Binary quasars have material ejected from the center. Simultaneous supernovas explains the Einstein cross. See part 1 of this video on Halton ARP's quasars.
And there are about 4 of them together. And the favorite explanation for this is that it's gravitational lensing. And they want to have them gravitational lensed by this foreground cluster here. But they never seem to notice that this foreground cluster extends right back down the line to this big, bright galaxy here. So this is just sort of a random example of the connection of these high redshift objects to the low redshift objects involving the clusters, which nobody can see, except if you look at it this way.